Hey everyone, welcome to another session of CeerazzleDazzlephysics. In today's session, guys, we're going to be looking at static electricity, guys. So put down today's title, it's going to be static electricity. Right, so first of all, let's talk about the following scenario. Right, okay, so over here, guys, you see I've got a diagram, guys. I've got a balloon on one side over here and a jumper on the right-hand side over here. First of all, the first thing to note is these two are insulators, so both are insulators. Guys, if you forgot what an insulator is, guys, they are poor conductors of electricity. So they're not very good at conducting electricity. So poor conductors of electricity. Excellent stuff here. Right, so if I take the balloon, guys, and I have the jumper, and if we rub them both together, something interesting will happen. So if we take that balloon and we have the jumper and we rub them together, something interesting will happen. But before we do that, let's talk about the charges within it. Right, so both these objects are neutrally charged. That means that they have an equal amount of positive and negative charges over here. So I'm just going to say they're neutrally charged by drawing some plus signs over here. There we go. 3 of them over here. And because it's neutrally charged, it has an equal number of negative charge. There we go. 1, 2, 3. There you are. It cancels itself out. I've got 3 positive, 3 negative. They cancel each other out. That's why it's neutral, because it has neutral charge here. And the jumper as well at the start, guys, obviously it has I'm going to do a bit more. There we go. It's negatively there, some positive ones, some negative charges over here. There we go. So this is at the start, everyone. This is the start before we rub them together. If we were to take the jumper and the balloon and you rub them both together, what happens is the negative charges, obviously, so let's just say we rub them together, so we're going to add some friction between them. Obviously, guys, add some friction between them. What will happen is the negative charges from one of them will go onto the other. So this negative charge from the jumper over here will move off and deposit onto the balloon. This one as well will move off and go over here. This one as well will move off and go over here, and this one as well, let's say it moves off and goes onto the balloon over here. Right, these small negative charges which are being moved off are going to be electrons. So electrons, guys, which are the negative charge, which are the negative charges are transferred from one object to another. Excellent stuff. So look, the electrons are then transferred from one to the other here. So what does it look like afterwards, guys? Let's draw it. What would it look like afterwards? And here we go, guys. You can see that, guys. We can see from over here. Look, now obviously this is the after stage. We can see that those electrons which from the jumper are now onto the balloon over here. And now the jumper over here is left positively charged over here. So what has actually happened, guys? First of all, the object which gains the electrons becomes negatively charged. Because look, the balloon gained electrons over here. So the balloon gains electrons. Balloon gains electrons and therefore becomes overall negatively charged, guys. Everyone happy with that? Yes, look carefully, obviously, because I've got 1, 2, 3, 4, 5, 6, 7 negative charges and 3 positive ones. So obviously that's the reason why. Yes, but there's more negative than positive. It is now negatively charged. And the jumper, which has lost electrons, will obviously become positively charged, guys. There you are, guys. So the jumper now loses electrons and it's now positively charged, guys, because it's lost those electrons here. Make sure you're happy with that, guys. Yes, so don't forget, you have the 2 insulators, guys. You rub them together, guys. Electrons are transferred from one to the other. If you gain extra electrons, you now become overall negatively charged. If you have lost electrons, you have now become positively charged, guys. So that is the key thing here. And right now, obviously, because they are insulators, the charge will be stuck on the surface of the balloon or on the jumper itself over here. This is called static electricity. The reason why is because the charge can't flow. So this is known as static electricity has been built up on the balloon and the jumper. So static electricity has now been built up. Good, so static electricity has now been built up on each object, guys. So static electricity has now been built up on each object over here. Fantastic. Yeah, make sure we're happy with that. Don't forget, the reason why it's called static is because the charge is not free to move. Like static. Static means you're not moving. It's the same principle here. The charge is not free to move over here. There we go. Here's the balloon and the jumper scenario. Fantastic. Right, so if you do this in real life, you take a balloon, you rub against a jumper, you notice that the balloon becomes charged. Then you might be able to see that some people will take that balloon and they can stick it to a wall. But how does that work? We're going to explain it right now. Okay, right, so here it is, guys. How does a charged balloon stick to a wall? So let's say we've got a balloon over here, guys, and look, it's got negative charge. Yeah, it's now negatively charged. So somebody's already rubbed it and it's now become negatively charged over here. How can we take that balloon and how does it stick to a wall? So let's say if I was to take that balloon, guys, over here, there's my balloon, and if I was to bring it closer to the wall, what would happen? If I bring it closer to the wall, what would you notice? What would happen here? Well, think about it. First of all, this is my wall. I didn't make that clear. This is the wall over here. If you bring it closer to the wall, you will notice that within the wall, those negative charges within the wall will be repelled away from the balloon, because the balloon is negatively charged. So here's the negative charges within the balloon over here, right? And the negative charges in the wall would move away. There we go. They would be repelled away. And obviously, the positive charges would then remain on this side over here. And look, guys, what would happen? Because you have the positive and negative charges right next to each other, you know the opposites attract. Therefore, the balloon sticks to the wall. So look, guys, over here. Now we have the balloon sticks to the wall. To the wall over here. And over here, this is the reason why a charged balloon can stick to a wall, guys. So you take the charged balloon, you bring it closer, and look, it repels away the electrons within the wall, and the positive charges over here attract the balloon over here, and we have the opposite charges ensuring that it's stuck to the wall over here. Okay, so the next thing we're going to look at is going to be the dangers of static electricity. Over here we've got a cloud, guys, and at the bottom, guys, this is the ground, yeah, the earth. Right, so what can happen is charges can build up within a cloud over here. As you can see, we've got some negative charges being built up at the bottom of the cloud. Well, the logical thing is this, guys. They can sense the ground underneath. So what will happen is all those negative charges will try and discharge back into the ground. Because imagine they're two negatives. They don't want to hang out with each other. So what happens, they will discharge back into the ground over here. So a lightning bolt can be released and it travels all the way down to the ground. It will take these negative charges over here and, guys, they move down to the ground over here. They move all the way down to the ground over here. In this case over here. Fantastic stuff. So that's going to be a danger of the static electricity, guys. You could end up with a spark. So sparks can occur. Sparks can occur. And obviously, guys, this can be quite dangerous. Imagine you're trying to refuel a vehicle, guys. So you don't want a spark to build up with the fuel because it could ignite the fuel and then obviously cause a fire or explosion. So sparks can occur. That's going to be quite dangerous, guys. And obviously, this is the physics behind lightning. Lightning, yeah, fantastic stuff. Okay, another one's going to be a use of static electricity. What could be a use of static electricity? Okay, so what about a use of static electricity? How can we actually use it? Well, what about this? Let's say we're going to try and spray paint a car. Okay, so let's say we're trying to spray paint a car, guys. So here we go, have a car over here, and we've got the paint on the left-hand side over here. So what we could do is this. If you want to be quite efficient with the fuel, you could do something quite nice. You could charge the car. Let's say it's positive. You charge the entire car positive, guys. Maybe you connect a lead to it. Here's my car. Entire car, you connect positive. And the paint you charge negative, guys. So the paint you charge negative. So we charge the paint. Good. So we charge the paint and car oppositely charged. Okay, so as you can see, guys, as the paint comes out, guys, it will be attracted to the positive charge over here, ensuring a nice, even, uniform spread, guys. And that's going to be a use of static electricity, guys, is to spray paint cars, guys. And obviously, guys, you're just going to conserve your paint, guys, because you're now using it resourcefully. Fantastic stuff. Okay, let's have a recap right from the top, guys, before we get going. Okay, so today's title was static electricity, and the first thing we did was the following. We talked about if you have a balloon and a jumper, guys, if you were to take the balloon and the jumper and you rub them together, what happens is obviously negative charges are transferred from one object to another. So at the top, we've said that the jumper is losing the negatively charged electrons to the balloon. So as you can see, guys, the balloon initially was neutrally charged, and so was the jumper. Both of them were neutrally charged. And don't forget, they're both insulators. But now look, as you can see, guys, as the balloon has gained those negatively charged electrons, it has now become negatively charged. And the jumper, which has lost those negative electrons, has now remained positively charged. So if you gain an electron, you become negatively charged. If you lose electrons, you become positively charged over here. Don't forget, now you have static electricity built up upon both objects. Obviously, one's negatively charged and one's positively charged over here. Then I said to you, how could you make that balloon stick to a wall? Well, you could do the following. So look, guys, you have the balloon and you have the wall over here. You can bring the balloon closer to the wall, guys, and you can see that the negative charges within the wall are moved away and the positive charges are lying up next to it. Therefore, as you can see, the negative charges of the balloon are attracted to the positive charge over here. And that's the reason why the balloon sticks to the wall, guys. That's the reason why the balloon sticks to the wall. Scrolling down, we then talked about the dangers of static electricity. We said that in a cloud, charges can build up. What will happen is the cloud will try and discharge itself back down to the ground. So it will try and discharge itself back down to the ground. The negative charges are going to transfer all the way down to the ground over here. And that's the reason why you have a lightning strike. The cloud is trying to discharge itself. Let me put that down. So the cloud discharges back down to the ground. There we go, guys. The cloud discharges back down to the ground over here. Fantastic stuff. Right, now scrolling down, guys, we then said the use of static electricity. Let's say you get some paint and you're trying to spray paint a car. You can charge the paint negative, you can charge the car positive, the metal frame. Then obviously when you spray it, the paint's going to be attracted towards the different parts of the car. And that way you can paint it with ease, guys, and obviously with efficiency. Excellent stuff. And that's it for another session of CeerazzleDazzle Physics. Make sure you hit the like and subscribe button to keep my channel going, and good luck in your academic studies. Ciao, ciao, and goodbye.